Find the vector projection of u onto v. Okay, let's just do that first part. Projection of u onto v. So projection of u onto v. U going in the v direction. U going in the v direction. So
Which one's u? Which one's
v is, upper one is the vector you want to break down. The bottom is the direction you want to go. Okay, so this is going to be u dot v divided by u or v?
V.
V,
V. Square.
the direction you want to go, times v. Okay.
Is that it?
No, you have to solve it. So v is the direction you want to go. V is the direction you want to go. And then so I try to tell people to do this last year. So this is the direction you want to go, therefore there are more of v.
Oh.
Okay, I don't know if that is a little better.
That's portion makes sense.
They're both on the bottom.
Okay, u dot v. 6.2 dot 5 negative 2, negative 5. 6 times 5 plus 2 times negative 5. Divided by magnitude of v squared. So basically just disregard that square root. So 5 squared plus negative 5 squared times v. V is 5 negative 5. So this whole thing is going to give you a scalar. And then make sure you multiply that scalar with a vector. Right? This whole thing is going to give you a number. And then make sure you multiply by the vector later. Okay, so this is 30 minus 10, which is 20, divided by 50. 2 over 5 times 5, negative 5, which is 2, negative 2. So u is whatever direction it is, v is whatever direction it is. There is 2, negative 2. If you break it down, 2, negative 2 is going in the v direction.
Wow.
All right, we are on page 9. We're going to finish the projection to figure out the orthogonal angles. Okay, so go to page 9. We're on that top part. I think I drew out a picture last time we were looking at this part. So we said that we are projecting u onto v. So let's, if you don't have a picture yet, let's draw u and v. U is 6.2. And v is, oh, I can't see it, 5, negative 5. One, 2, 3, 4, 5, 6, 2. Maybe I need to make it shorter. Cannot make it shorter. Six, 2, and then 5, negative 5. 1, 2, 3, 4, 5. Okay, this is v. Okay, so we are projecting u onto v. I think I'm pretty sure we did this last time. So the amount of u going in the v direction is if you draw a straight line down that is perpendicular, and you're saying how much of u is going in the v direction, right? You got this? And then we said, the calculation says 2, negative 2, and then we looked at it and we said, yep, that looks about 2, negative 2. Okay, now this is the part on the homework that you probably couldn't do, which is the second part. The problem says, let's have you write this projection as a sum of the projection vector and another vector that is orthogonal, so that when you add them together, it becomes u. Okay, so looking at this diagram, you have a projected vector here. Which part, okay, which, I guess, line on here is orthogonal to this vector, to this projected vector? Where is it that's orthogonal to this projected vector? Bad question. Okay, so the red one is the projected vector. Yeah, I'm gonna make this green. Okay, so the red one is the projected vector. Which part is the part that is orthogonal to it? Is it the green one or the blue one? U one. The green one. The green one is orthogonal, right? 90 degrees. Okay, so we are going to write U as a sum of the projected vector and something that is 90 degree to it. So U, yeah, U is the sum of the projected vector plus the 90 degree vector. Okay, so and remember when you're adding vectors together, Peter, are you with us? Okay, so when we're adding vectors together, we have the tail to head method, right? So if you have a vector pointing this way, you have a vector pointing this way, the sum is you when you add the tail to the head. Yeah? Okay, so it's like a few days ago. Okay, so let's call this green vector. Let's call this green vector, let's say W. Okay, so we can say that the projected vector is projection of U onto V. U onto V plus the W vector has to equal the U vector. Okay? What is the vector? What's the actual component form of the projected vector? Yeah, 2, -2. We don't know what the W vector is. What is the U vector?
6.2.
6.2. Yeah, 6.2. So to find the W vector, you're just going to subtract the vector. So 4, 4. All right, let's see. Is 4, 4 really the answer? You guys all understand how I got 4, 4, right?
No. Yeah.
Okay, so let's look at 4, 4, where 4, 4 is. I'm gonna put this in yellow. 4, 4 is this one. The question is the yellow and the green the same vector?
No.
Remember, vector is defined by two things, right? What are those two things? Magnitude and direction. So ask yourself, is the yellow and green, do they have the same magnitude? Do they have the same length? Yes, looks about right. Are they pointing in the same direction?
Yes.
Yes. So are they the same vector?
Yes.
Yes. Okay, it doesn't matter where they are in space. As long as they meet those two requirements, they are the same vector. Yeah, so vector is kind of strange. It doesn't matter where they are in space. As long as they have same length, same direction, they're the same vector. Okay, so we can see that they are the same, so that means our calculation is correct. So the projection vector plus this orthogonal vector is equal to U vector. Okay? All right. Should we do a problem or should I just let you guys? Huh? Do a problem? Let's do a fun problem. Let's do a physics problem. I really like physics, but I'm not very good at it. Okay, Juan is sitting on a sled on the side of a hill inclined at 45 degrees. All right, so there's this incline that is 45 degrees, and Juan is sitting on the sled. Okay, the combined weight of Juan and the sled is 140 pounds. What force is required for Rafaela to keep the sled from sliding down the hill? Okay, so he is sitting on this sled on this hill. Obviously, if nobody holds him, he's gonna slide down, right? But Rafaela is gonna pull on him and the sled to make sure he doesn't fall off. The question is, how much does she have to pull so that he doesn't fall? And it has to do with his weight, right? The heavier they are, the more she has to pull. Yeah? Okay, so let's think about it. 140 pounds. Gravity points which direction? Straight down. So that 140 pounds points straight down. Sorry, just 140, not degrees. Which direction does Raphael have to pull?
To the 45 degree line.
To the 45-degree line, like pull him up, right? So she has to pull this way. Okay? The amount she's going to pull is going to counteract with how much he's going to fall. Yeah?
But why he have to pull? Why can't he just use downwards? Why he has to pull?
Why does she have to pull?
Yeah.
She has to prevent him from falling down.
But if he sits on the table and there's a downwards to the hill, that's
Huh?
never mind.
Okay. All right. So she's gonna pull. If she pulls harder, he's gonna go backwards, right? So it has to be just right, exactly, right? The question is, how much of that force do you need? Well, it has to do with this angle. The question is, what is that angle? It's not that hard. Why is 140 going down? Because gravity goes down.
It's his weight.
Yeah. Okay, so what is that angle there? 45, because this is a 45, 45, 90, right? So this is 45 degrees. All right. Talk to your partner. How much of the 140 is going in the 45 direction? Think projection, I guess, in a way. How much is 140 projected in the 45 direction? Okay, if this is very difficult, think about it this way. This is what I want you to find. I want you to find x.
Oh, on the
All right. Okay, how do we figure out x?
Cosine 45.
Yeah, so 140 cosine 45. Okay, which is what?
99.
99?
If you use sine, you give you the same answer.
Sine would be this one.
Oh yeah.
So that would not be where Rafaela is. Okay, so the answer is 99 pounds, I guess. Huh? No? Is it wrong? Oh, okay.
Yeah.
All right, so that's how you solve this kind of, yeah.
She meant from the other end.
Yeah,
because
because
the
it
other
was
one's 45 too.
Oh, for this one, I guess it didn't
Yeah,
matter.
because I did sine and it worked.
Yeah,
I
yeah,
don't know
right.
why it didn't work.
Because this is a isosceles triangle. Okay, that is it. Let's move on to 6.3, which is really easy. Okay, we already did this in chapter 1. Parametric equation. I'm going to show you how to do this in the calculator, so then make sure you have your calculator out. Okay, so remember, this is something like this. If I have this marker and I'm going to go like this, so then, a little farther. So at time 0, it's right here. At time t, maybe 1 second, it's right here, right? So that means there's an x direction in terms of time. There is a y direction in terms of time. And then 2 seconds, maybe it's here. There's an x direction in terms of time and then y direction in terms of time. So we are going to look at this kind of equation, which is called parametric equation. Parametric means that it's in terms of a parameter, and that parameter is time, or t. Okay, so let's look at this one. X is equal to t squared minus 2, y is equal to 3t. We want to figure out where this object is anywhere in time. So, do you guys remember this at all or not at all? Okay, we probably did it too little for you guys to remember. Okay, so we have t, we have x, and we have y. T goes from -3. Let's just graph the first one. -3, -2, -1, 0. Sorry, just -1.
Oh, I remember.
Remember this? So just graphing it, and then so x is equal to t squared minus 2. So when t is negative 3, just plug it in. You get 7. Y is 3t. So when t is negative 3, y is negative 9. Are you guys good? Easy stuff. Okay, so go ahead and just do those numbers, and then we're going to graph them. Okay, so it goes 2, negative 6, negative 1, negative 3. So let's go ahead and graph it on here. Let's make sure I have enough space. Okay, so at time t equals negative 3, x is 7, y is negative 9. Negative 9 is around here. Okay, so this point is t equals negative 3. So at t equals negative 3, the coordinate is 7, negative 9. Okay? At t equals negative 2, the coordinate is 2, negative 6. 2, negative 6. At t equals negative 1, the coordinate is negative 1, negative 3. Are you guys good? Okay, it's very kind of not interesting to see this segment of the line. It really doesn't tell us anything. Let's graph more. Let's graph all the way up to 3. Yeah, a question. Did I write the wrong number?
It's supposed to be -1, -3.
Negative 1, negative 3.
One.
Should be 3.
Oh, yeah.
Huh?
Yeah,
On the third area.
T equals negative 1. And
Negative 1, negative 3, right? Right. Yeah, sorry. Oh, cannot erase. Negative 1, negative 3. All right, thank you guys. Okay, continue graphing up to 3. Okay, so you guys can see that it looks like this, right? Did you guys get that?
Yeah.
Okay, so basically, what shape is this one? Curve? What kind of curve? Huh? Yes, parabola, a sideways parabola. Okay, so the next thing we're gonna do is we are going to combine these together so that we get rid of the parameter. So we're going to combine x and y together so there's no t. All right. So either we write the equation x in terms of y or y in terms of x, but there's no t. What do you guys think? How should we do that? How do we write the equation so there's no t? Replace
T.
how?
Oh, you could do T equals Y.
Yes, that's correct. So to eliminate something, we change that variable in terms of something else, and then we substitute. That way, t is entirely gone. Okay, so we're going to substitute that in here. So t is equal to y over 3. So this is y over 3 squared. So this equation now becomes x equals y squared over 9 minus 2. If you recall, y squared over 9 minus 2 is a sideways parabola. So that is the same equation. Now, can you write this in terms of y equals blah, 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 blah? X? Yes. But just make sure you have plus minus. Do you guys need some help on this one, or you guys are okay? Okay, the next thing is take out your calculator. I'm going to show you how to graph this on your calculator, the parametric equations. You're really going to get your calculator's worth this year. I'm going to teach you like half of the stuff you can do on your calculator. Because half will be next year in calculus if you want to do that. Okay, so take out your calculator. You are going to go to mode. Go to mode on your calculator. Okay, if you scroll down to the fourth line, your calculator should be mode. Your calculator should be in FUNC right now. That means function. So that's why when you graph something, it's always y something something x. You're going to scroll over to right one, where it says PAR. That means parametric. Okay, and then press enter. When you press enter, that's going to be highlighted. That means you're now in parametric. Okay, now if you go to where you usually graph things, everything is in terms of t. X1 t, y2 t. That means you're graphing x in terms of t, y in terms of t. So what you're going to do is you're going to type these two in. T squared minus 2 and 3t. Now don't worry about trying to find where t is, because if you just, it does it automatically. It knows you're in parametric. Yeah, it's no longer x. Okay, so if you just press the variable button, it will say t.
Oh, wait.
All right, so, Okay, so now what you're going to do is type that in. T squared minus 2 and 3t. And then just do zoom 6. Just, I don't know which window you're in, so let's just do zoom 6. That will graph this function. Now, if you're not looking at a parabola, then something is not right with your setting. And that is because this part, the t limit. Okay, so we need to change how much time to graph. So what you want to do is go to window. If you click on window, it's going to ask you what is the minimum t you want to graph. So you might want to start at -3, since we did -3. And then go up to 3. And you should be able to see a parabola now.
Go to mode and then it'll say. Go to mode and it'll say.
Now, if you still don't see a very nice parabola, you might need to change your t-step. Your t-step might be too high. So basically, it's like graphing. Mine was graphing every 7.5 seconds. So basically, it had 2 dots, or actually 1 dot. So you might want to change it to 1. So you're graphing every second. So then it should look like this. Nice parabola. Everybody's got it. Yeah. Oh, why is yours pointing the wrong direction?